Welcome to Study Loop.
Hello, in the question we have given that two sheets of aluminum foil has have separation of 2 millimeters. So this D is given, that is 2 millimeters, and capacitance, let us call it as C1, that is equal to 20 picofarads is given, and our charge to 12 volt. So let us call V1 is equals to 12 volts. So the separation is now decreased. So D prime will be equal to 2 minus 0.2 millimeters. So this will be D prime will be 1.8 millimeters. So is decreased. The separation is now decreased by 0.2 millimeters while charge held constant. So we have to find out the potential difference change. So change in the potential difference. So delta V is what we need to compute over here. So now charge is constant. So one thing over here is given as charge is constant. So when this distance is changed, the distance between these two plates is changed, the charge still remains the same. So we can use the thing over here. So we know that Q is equal to C times V. So I can write Q1 is equal to C1 V1 and Q2 is equals to C2 V2. So as charge is constant, so I can equate this to equations. So I can get C1 V1 is equal to C2 V2. So now this is one equation and there are two unknowns over here because C2 is not known, V2 is not known. So now let us first calculate this C2. So we know that C is given by epsilon naught A divided by D. So if I take the ratios, so C1 will be equal to epsilon naught A by this D and C2 will be equal to epsilon naught A by D prime, because like when we are changing the separation, so it is D prime. So now from this I can just take the ratios. So C1 by C2 will be equal to, so this will be epsilon naught A by D divided by, so this is epsilon naught A by D prime. So area remains the same. So this gets cancelled. So I will get from here C1 by C2 as equals to D prime by D. So from here C2 we need to calculate. So C2 will be equal to then, so C2 will be D by, so I'm bringing this over here. So this will be D by D prime times C1. So if we plug the value, so D is 2 divided by D prime is 1.8 times C1 is 20. So from here if we calculate, we will get this as 22.2 picofarad. So this is the value of C2. So we have calculated C2. So we will use this over here in our equation. So this equation, in this equation we will use. So let us first, so I will write it once again. C1 V1 is equals to C2 V2. So this was the equation we had. So let us rearrange for V2 first. That is what we need to calculate. So this will be C1 by C2 times V1. So this is C1 is 20 divided by C2 is 22.2 times V1. So it is V1 is 12 and that is V2. So if we calculate this V2, we will get it as 10.8. So if we take the change, so delta V will be V2 minus V1. So V2 is 10.8 minus 12. So this will give me the change in the potential as equal to minus 1.2 volts. So minus sign indicates that the potential has been decreased. I hope you find the solution useful. Thank you.